Now let's look at the next problem where we have to find the intersection of two arrays. So the problem statement says that you are given two arrays, namely nums1 and nums2, and we need to write a program to return the intersection of both arrays. So here two things that you need to understand mathematically. One is intersection and the other one is union. So in the problem statement we are asked to find the intersection. Intersection is nothing but whatever the common values we have in both the arrays, that we need to find. That is what the intersection means. Union means combination of both the arrays. So just combining both array values, that is nothing but union. Okay, so here we need to find the intersection and we need to return that. So if we see here, that is what the definition that we have gotten about what exactly is intersection of an array, and the constraint that we have gotten is every array will have unique values in it. So every array will have unique values. That means that not even any single value will appear twice. So we don't have to worry about any of the duplicates. Now if we look at the examples here, this array has the value 10, 1, minus 2 and 3, and this array has the value minus 1, 3, 2, 1. So out of these two arrays, the common values are nothing but 1 and 3, and that is what we have returned. So here if we look at the second example, the first array is empty and the second array is not empty. It really doesn't matter, since the array 1 doesn't have any values, we will not have any common values between those two. As a result, the result also is an empty array or list or set. Based on your programming language choice of implementation, you can return it appropriately. Now here in the final example, both the arrays are empty. As a result, the output array is also empty here. I hope that gives clear-cut understanding of what exactly we are trying to do here, and let's dive into various techniques for solving this specific problem. Alright, now let's try to understand the brute force approach for finding the intersection of two arrays. So here very straightforward, we will iterate over first array, and then inside that iteration we will iterate over the second array, and we will pick up the value from the first array and we will pick up the value from the second array. If both of them are matching, then we will put it onto a result array. So here I will directly write the pseudocode. So here we will write one function called find intersection from two arrays. So this will take array 1 and it will take the array 2 as well. Immediately what I will do, I will initialize a list or set or any data structure. Into this list I will keep on adding the values that I find in the iteration process. So immediately what I will do, for I equal to 0 to I less than length of array 1, and each and every step I'll increment by 1. Inside this what I will do, I will run another loop, j equal to 0 to j less than length of array 2, I'll increment it by 1 again. Now what I will do, I will compare the value from ith index is equal to, ith index is nothing but first array, j is nothing but second array. So array 1 of I is equal to array 2 of j, then both of them are having the same value. Then what I can do, add on to result. Okay, if this is not the case, we will simply move on to the next index and the same logic keeps on going. In the end we will return this list whatever we have constructed. Okay, so this is the brute force approach. What we have done, we picked up the value from first array and we will compare that value with the value we have in the second array. So that is pretty much straightforward. So if we understand the time complexity here, it will be order of n and it will be order of n, assuming that both the arrays have the same number of values. Let's just say one array has m and other array has n, then inner loop will be n and outer loop will be m. But in the worst case, the time complexity will be the bigger array 1. So the time complexity for this overall will be order of m into order of n. If both of them have the same length, which is n, if we assume, the time complexity will be order of n square. Okay, so that is the brute force approach. Now, is there any better way to bring down this time complexity from order of n square to some other better time complexity. That is what we will be checking. I forgot to mention the space complexity of this will be, constant only. Here we will not consider the space that we are using for constructing the result list. That is what we need to return in the end. So the memory consumed by it will be, unavoidable. But the process of finding the values and adding that onto the list, we will not consume any memory besides some temporary constants. So the overall space complexity will be constant only. Okay, so that is the space complexity and that is the time complexity. Now let's go ahead and find the other ways in which we can solve this problem in a better time. The next technique using which we will bring down the time complexity of the solution for finding the intersection values out of two arrays is with the binary searching technique. Okay, so binary searching technique. What I do is, binary searching technique can be applied only on the sorted array, right? So here what I will do is I will sort one of the array. So here in this case I will sort the second array. So array 2, if I sort, the resulting array will be -1, 1, 2, 3. Now what I will do is, whatever the iteration logic that we had here in the brute force approach for the first array, that we still have, but for searching that specific value inside the second array, we will not write one more for loop for all the values. Rather we will simply be using the binary searching technique. So that is the entire modification that we will do here. So if I directly jump into the pseudocode, because it is pretty much straightforward, right? We will pick up 10 and we will search if 10 is there inside this array using binary searching technique. If it is not there, we will not add into result list. Then we will move on to the next value. Again, next value we will search inside the same sorted array. If we find an index, we will add that index value into the list, and the logic keeps on going. So here ultimately the total steps are, let me just write the pseudo code itself, because the process is very much straightforward, right? So find intersection in two arrays, a function, it will take array 1 and it will take array 2. Immediately what we will do, we will sort the either of the arrays. So I am sorting the second array here. So it can be merge sort, quick sort, anything. So immediately what we will do after that, we will write a loop. Here we need to write a loop on a non-sorted array. Since array 1 is not sorted, I will be running from 0 till length of array 1, where we will run till the last index, right? Immediately what I will do is, I will write one function called binary search. What it does, it will take the array of values and it will take the search value as well. If this search value is found, it will return the valid index, otherwise it will return -1. So traditional binary searching function that we have already implemented when we discussed binary searching technique, right? We will have the exact value. Immediately what I will do, I will call this binary searching function with the sorted array, which is nothing but array 2 and the value from array 1 at ith index. If this index is found, then if at all this index is not equal to -1, then we have the valid index. Then what we can do, before here I will initialize one list called result list or something. Into that result list add whatever the value. If we got not -1, if we have gotten any other value, right, that means that value is available inside the array in second array also. That means it is already there in the first array as well. So immediately what we can do, array 1 of I, or even you can do array 2 of index also, because both of them will have the same values. Okay, so that is the pseudocode. In the end we will return the result list. Okay, so that is the logic here. Now if we understand the time complexity, here for this binary searching technique we will be taking log n units of time. For this outer loop, if we assume that it had m number of elements and second array had n number of values, the binary searching technique will take log n units of time, and the outside for loop will take m units of time. So the overall time complexity will be m into log n, and the space complexity will be constant only. So technically we have brought down the time complexity of m into n to m into log n without consuming any additional memory. So that is an important point here. Here we have not consumed any additional memory. Okay, so that is what we have to understand. Now let's see if we can do even further any modification that we can do for the solution that we have to write for finding the intersection, so that we can bring down the time complexity further down. So without consuming any memory, that is not going to work out, but by consuming some additional memory we can bring down the time complexity. That is where we will be constructing a hash map with one of the array, and we will search another array values inside that hash map. So that is what we will be doing. So first of all, what we will do is we will construct a hash map with the one of the array. Here the array is nothing but array 1 I am assuming. So what we will do, hash map is nothing but key value pair, right? So here key is nothing but whatever the value that we get. So 10 we will be putting, and key is nothing but 10 itself, and the value you can put anything, it really doesn't matter. Here we are not going to do anything with the value portion of the key value combination of the hash map. So here what I can do, I can simply put the index itself. 1 is another value, it is at index 1, minus 2 is another value, it is at index 2, 3 is another value, it is at index 3. So this is the hash map. So first we have iterated over the first array and we have constructed a hash map out of it. Now what I will do is I will iterate over the second array and I will check if this value is there inside this hash map. If so, that is a common value and we can add it onto a result list. So very simple one, we will pick up minus 1. Minus 1 is not there anywhere in the keys of the hash map. So it is not a common value. We will move on to the next index where we have the value 3. 3 is there inside this hash map also. So the intersection will be having the value 3. Next we will move on to 2. 2 is not there inside this hash map. So it is not an intersection value. And 1 is where we have, and 1 is there in the hash map. So we will put 1 onto the result list as well. So the intersection values are nothing but 3 and 1. Okay, so that is the logic with the help of a hash map. So first iterate over the first array, construct a hash map out of it, and then iterate over the second array and search if that value is there inside the hash map or not. So that is the hash map based solution. So if we quickly write the pseudo code, what we will do, we will write one function find intersection of two arrays, array 1, array 2. First what we will do, we will initialize a map. So immediately what we will do, we will need to iterate over a variable I 0 till length of array 1. Immediately what we will do, we will check if this value is not there in the map, because anyway the problem statement mentioned that we will get the unique values. So we don't even have to worry about checking if the value is already present in the map or not also. We can simply put array of I into map. Okay, so once this for loop is done, we will have all the keys into the map. Now what we will do, we will iterate over another loop 0 till length of array 2. Immediately what we will do, we will check if array 2 of I is present in map. If yes, then add on to a result list, or put or add on to result list. Okay, if it is not there, then we don't even have to worry, we can simply move on. So this is the logic. So here obviously we will be constructing a result list, right? So before we start the second loop, we can initialize that result list. Okay, in the end we will simply return that result list back to the user. Okay, so that is the hash map based solution for finding the intersection of two arrays. Now let's try to understand the time and space complexities of this one, right? So here we have initialized a map and then we have iterated over the first array. Let's assume that it has m number of values and the second array has n number of values. In that case, we had to write a iteration logic m number of times. Putting anyway will take constant amount of time only, and after that we will write another loop which will take n number of iterations. Again, checking and adding will take constant amount of time only. So overall time complexity will be order of m plus order of n. Okay, now the space complexity will be, here we are initializing a map. In this map we have put all the values of the array 1. Since it has m number of values, the space complexity will be order of m. Okay, so here whatever the time complexity expression that we have gotten, which is order of m plus order of n, right? Let's assume that if both the values have same number of values, in that case order of m plus order of m, if we assume m is the common value, then the time complexity will be order of m and the space complexity will be order of m only. So we have brought down the time complexity from order of m log m to order of m itself. Okay, by consuming an additional memory of m units. So that is an important thing here. If your interviewer asks you to write a better solution without consuming any memory, you need to write the binary searching technique based implementation. Otherwise, if your interviewer is okay with consuming some additional memory, you can write the hash map based solution for finding the intersection. Okay, now that we have understood this, let's quickly go ahead and write the binary searching technique based implementation, and you can find this hash map based implementation on codingpile.org, which can be reached using the problem link in the description. Okay, thanks for watching. Again, I'm mentioning, before you go ahead and check out the implementation, try to write the implementation all by yourself. If you are facing any difficulty, you can check out that video. Even after that, if you have any problems, you can reach out to me. I'll try to help my level best. Okay, that's it for this one. I'll see you in the next problem.